Hi, AB Calculus. We are now on 2004, question number 2. Something I didn't think about. Some of you might not have graphing calculators. If you don't have graphing calculators, still set everything up. But you can go to desmos.com and use that as a program that can do graphing. It can do the integrals for you. There's other websites that have graphing calculator capabilities, but Desmos.com definitely works, and you're smart people. Look up some tutorials and things like that. You'll be fine. All right. This question number 2 has a bunch of stuff that's not on the AP exam. But, many of you are going to go ahead and take more calculus after this class, so you have to know this stuff anyways. So I'm not going to teach you less stuff, okay? We're going to do questions that aren't on the AP exam anymore, and that's okay. If you're wondering, what are you talking about, Mr. Pygott? If you go to my link from March 21st, I discuss, it's all typed out, it's in a Word document, but some of the items that are no longer being tested because, obviously people aren't in school and some teachers didn't get to teach everything. So parts of this question aren't on the exam. That's okay. We're still going to do it. You still need to know how to do it. And 11th graders who are back next year for BC Calculus, you need to know it anyways. All right, so here I have my 2 equations. I put this one in y1 and this one in y2. And now I'm just going to go ahead and answer my questions. So number 1 says find the area of the region. I have a graphing calculator. This is basic. Area of a region is where does the region begin and where does it end. I highly recommend making sure you are 100% certain that they meet at 1. Okay? If you do graph both of these, they do meet at 1. You can even plug a 1 in here. If you plug in a 1, you'll see you'll get 0. If you plug a 1 in here, you'll see you get 0. So they definitely meet there. So the area of a region, and this is part A, is just the integral from whatever to whatever, so from 0 to 1, and then top equation minus bottom. Now I could write out the top and the bottom equations here, but as long as I just put in f of x and g of x, that's a lot less work for me. But do make sure you have parentheses so the dx belongs to everything. Now I'm going to use hotkeys. Because I put this in y1 and y2 in my calculator, I can do that. And in fact, you can put y1 and y2 in your work as long as you say let, you have to say let y1 equal all of this, and let y2 equal all this, and then you can actually use y1s and y2s. Alright, so I'm going to type this in. So I hit math 9 from 0 to 1, top equation minus bottom, y1 minus y2, and I get my answer of, calculator's thinking, same thing I got over here, yep, 1.1333. Okay, that's first one. Second one, it's asking me to rotate around the horizontal line y equals 2. So here's the horizontal line y equals 2. When I go to rotate this thing around, it's either going to be a disc or a washer, and because of all this open space here, when we go to chop this up, we're going to have a washer. We're going to have circles with circles cut out. So the moment that I know I have a washer, I'm going to get my washer set up. I have pi from 0 to 1, and then outer radius squared minus inner radius squared dx. Okay, now outer radius is always the furthest one away, so I start here and go to the furthest one. That's going to be my outer radius, and then the closer one is my inner radius. So my outer radius is this, that's the further piece rotating around, and this distance here, this outer radius, is just top minus bottom, so it's 2 minus g of x. If you don't want to use g of x and you want to put that whole equation there, have fun. I just don't like writing. And my inner radius, again, is this right here, which is top equation minus bottom. That distance is 2 minus f of x. And I'm done. And again, I want to save, I'm going to use hotkeys. Alpha trace, oops, that's not y1, that's going to be y2. And that's going to be y1. And that's going to speed things up when I go to type this in. So I first put my little pi button. I like just using the pi button in here. And then math 9 from 0 to 1. And then my first set of parentheses. In parentheses we have 2 minus what's in y2 squared minus, and then we have 2 minus what's in y1 squared, and waiting for my answer. Wait, and I get the answer of 16.179-ish. So 16.1792. Now if you did not use the pi button, you would have gotten something near 5.15 pi. So you can either leave the pi out or use the pi in your calculations. Alright, this gets us to part C. Part C says, let h of x be a function. Alright, and they basically are talking about a graph of h and g. So f is no longer involved in this problem. So I'm going to go over here and, hi, I'm still here, I'm just off the screen. Magic eraser. I'm going to change this to h of x. And if I change that to h of x, let's see, it's instead of a 2, it's a k. Alright. Now, first, how does that change the graph? So, let's start with that. We don't know what k is. The one thing they tell me about k is that k is greater than 0. So try putting some positive numbers there if you want to try. We already know what it looks like when a positive number 2 is there. Put a 3 there, put a 4 there, put a 5 there. And here's what you're going to see. You pick any positive number in the world, and this is going to look like, if it's a smaller number like this, if it's a bigger number like this, make it a 10, make it a 20. But what you're going to see is no matter what, and imagine distributing this. If you distributed this, you would have an x squared piece that has a minus sign in front. Of course, a k would be in front as well. Let's make some space there. Wasn't dry. Come on, Pygate. Playing better. Oh, there it goes. Okay. So if you were to distribute this, your leading piece would look like this. That right there, that k, is positive. So this is going to be negative k, so it's going to be a negative x squared piece, which means it's a parabola facing down, and your zeros are still going to be 0 and 1. So these are just the different ways that h of x can look. Not much really changes, and g of x is still down here. So here's g of x, and h of x is just going to be any one of those. So I'm just going to go ahead and randomly keep one of these. And we'll call it h of x. Okay, so that's about what the new graph would look like. And it says we're going to chop, 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 make some cross sections perpendicular to the x-axis, and we want the volume to be 15. Okay, and thankfully they say don't solve, setup only. So we'll do that. So we're going to chop this up, and we're going to build out rectangles. Remember how this works? Way over here, we'll have little, not rectangles, sorry, squares. Here we're going to have little squares, big squares, and back over here, little squares again. So the idea is we're building out towards you these squares. And I go chop, 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 and I reach in there, I'm going to grab one cross section. And that one cross section, there it is. That's one of the cross sections. That's one of the squares coming out. If that's an S, that's an S, and the area of one of those cross sections is S squared. So one cross section is S squared, and remember this distance of S, we always just say top equation minus bottom. Now I could put this minus this, or I could just simply write h of x minus g of x, and that's S squared. Now from here they say, well that's not the volume, that's just one cross section. We need to add up all the squares starting from here all the way to here. So to add them all up, we're going to integrate from 0 to 1. And that right there will add up all the cross sections, all the squares, starting at 0 going to 1. Alright, so the problem finishes by doing this. And I'm finished. There's nothing else to do. The only thing, again, you could have done differently is here where it says h of x. If you wanted to see k in the problem, you could put your h of x here, kx, 1 minus x. And then when it says g of x, you could have put the g of x equation. But the idea is they wanted something that you could use to solve, and all we wanted to know is when this equals 15. So we set up an equation that says don't solve, where this would equal 15. I did it, and I'm happy. Alright, that's question number 2.